transformations of other trig functions. So the first thing that I have is a slightly complicated one. So we've got 2 sine of x plus pi thirds minus 1 on the interval from 0 to 4 pi. First graph sine of x, then find the amplitude period in this thing called the phase shift. So and then in parentheses, describe what the phase shift is. The phase shift describes how the function is moved to the left or right. A positive phase shift means you go to the right, and a negative phase shift means you go to the left. So first of all, before we start graphing, does it make sense that this 2 is going to be a vertical stretch? What is x plus pi thirds going to do to that picture? Left or right, and how much? Left pi thirds. And what's the minus 1 going to do? Shift the whole thing down 1. Now, what I actually think would be best to do is instead of graphing sine x, let's graph 2 sine x. I think that'll be a little bit better. And if you happen to have colored pencils or pens, that would be really helpful now, but you could also like draw some things dotted or dashed or solid to keep track of them. Okay, and just because it'll make it a little bit easier, I am just going to call this 2 and call that negative 2. Does that make sense? Like, as long as you label your axes, you can call them whatever you want. Okay, and I said 0 to 4 pi, so we'll say this is 2 pi. There's 4 pi, there's pi, 3 pi, and then the other ones are half pi's. So where does sine start? 0, 0, yes. And by pi halves, sine will usually be up at 1, but since we're graphing 2 sine x, it's going to be up at 2. By pi, you're back to 0. By 3 pi halves, where are you at? And then back up to 2 pi. And then the pattern repeats. Do it again. So there is your roughly speaking, your 2 sine x curve. Okay. And the question is, how the heck do you handle moving something over pi thirds? Does that make sense? And here is the awesome trick for that. To get to pi halves, you divide the interval, that little interval, into thirds, so into 3 pieces. And if you divide that into 3 pieces, the first one is pi 6, the second one is 2/6 or pi thirds, and this pi halves is 3 pi 6 or pi halves. Does that make sense? If you think about those in terms of angles, pi halves is 90 degrees, and so it's 30, 60, 90. Okay? So then to move this graph to the left pi thirds, this point that is at pi halves is going to go backwards pi thirds. So the distance that is pi thirds is 2 of those little ticks is pi thirds. Does that make sense? So this point right here, what's it going to now be above? Pi 6. Does that make sense? Because it goes backwards pi thirds, and so that's the amount it moves back. So that point's back there. So it moves backwards 2/6. And so there's the thing that's been shifted Yeah, that's just the backwards part. What's the last thing you have to do to shift it? Down one, yep, exactly. And since we counted by twos, this would be 1, this would be -1. So the highest point that was at 2 will now be at 1. Does that make sense? And the lowest point that was at -2, where is it going to be now? -3, yep. So move every point down 1. And there's sufficiently, like, lots of points to move with these. I think it's easier to do these in 2 steps as opposed to 1 step. If you can do it in 1, that's great, but you have to be accurate. Okay. I'm gonna draw that a little bit thicker just so you can actually see that's the final answer.
Don't you erase anything behind 0x because the interval is 0 to 4 pi?
Yeah, so technically you'd have to also go like a little bit past the point that I gave you, but it's okay. Like, it's not, if you graphed a little extra, I'm not going to be frustrated by that. Does that make sense? Okay, because it's mostly the case that the details, I think it's not very, very hard to understand how the shifting for this is the same as shifting for other stuff, right? But the details of where those points are can be pretty tricky, right? Okay, and I think that I asked for a bunch of other stuff in the directions, like, what else was there? The amplitude, right? So what is the amplitude? 2, yep. So that is, you can think about this as 2 ways. You can think about it as when the graph was unshifted, how far does it deviate from the x-axis? Or you can take the total height, which is 4, and divide it by 2. Okay, what else did I ask you to find? The period, is that also possibly one thing that I asked us to find? Yep, the period.
2 pi.
The period is 2 pi. That's how long one cycle is. And then the phase shift. So that tells you, did this thing shift to the left or the right? So positive phase shift means the picture went right. Negative phase shift means it went left. Which way did our picture go? Left. So the phase shift is negative, and how much did it go left? Pi thirds, negative pi thirds. Great. Okay. So what we're going to do now is just talk about some functions, and we're not going to actually graph them because it's just super tedious. Just find the amplitude, period, and phase shift, that's all. So this one's a bit different because there's this 3 in there with the x. So I think the best way to deal with that is to factor the 3 out. So we take the 3 out, you have 3 times x plus. When you factor that 3 out, you divide the remaining terms by 3. Does that make sense? So what is pi quarters divided by 3? Pi over 12. How could you check that you've done that correctly? Because if you just weren't sure if it was pi 12 or something different, how would you know what you had was right? Just distribute it back out. And does 3 pi over 12 make pi quarters? Yes, it does. Okay, so this -3 is going to shift the graph down, right? The 1/2 will affect the height of the graph, or the amplitude, right? What's the negative going to do to it? Over the x-axis, right? This 3 will affect the period, and this x plus pi 12 will be the phase shift. So first of all, what number is the amplitude? That's the easiest one to see.
-3.
No.
Oh, just 3.
No. 1/2. So the -3 describes a moving up or down, but it's the thing that's multiplied by the cosine that affects the amplitude. That's the thing that affects how tall your graph is. When we had stuff like just cosine of 3x, how did we find the period? That would have been on Monday. Do you remember?
3x equals 2 pi.
you set 3x equal to 2 pi. And whenever 3x gets to 2 pi, that's how long it takes you to get through one cycle. So this one, the fact that this is a 3 means you do it the same way. You set 3x equal to 2 pi. What is that plus pi over 12 going to do? That's going to shift it left or right. So it won't affect how quickly the function oscillates, but it will shift it around. So then this means x will equal 2 pi thirds. So it takes 2 pi thirds to go through one cycle. Okay, so what we'll have is the graph of y equals 1/2 cosine of 3x. It's shifted down 3. That's what the minus 3 does. What about the x plus pi 12? Does that do a left or right?
Left.
Left pi 12ths. So in that case, left pi 12ths, is that a positive or negative phase shift? Negative. So the phase shift is pi over 12.
So if that 3x was a 4x,
Mm-hmm.
then when we do the period, it would be 4x equals 2 pi?
Exactly.
Would be
Yep.
Plugging that in, okay.
Yep. It's always, yep. And it's because it takes cosine and sines periods are 2 pi. So whatever number you have times x equals 2 pi, whenever your expression gets to 2 pi is when it's going to be over. Yep. So for cosine and sine, it's always 2 pi. For tangent, it's a bit different because tangent's period is different.
Do we have to specify whether the phase shift is left or right?
Oh, I made a boo-boo. It should be negative pi 12ths. That's how you specify. Does that make sense? Yeah, okay. Thank you for checking my brain dead brain. Okay. How about this one? So you have a 2 with that x again, so you got to take that 2 out. So 1 plus sine parenthesis 2 parenthesis x plus, what will that become when you take out the 2?
Pi over 2.
Pi over 8. Great. Think if you've got a quarter of a pizza, you divide it in half, you each have an eighth of that pizza now, right? Which is less sad. Okay, which number will describe the amplitude or the steepness of the graph?
One, it's not there.
The one that's in front of the sine, which is a 1. So the amplitude is 1. To find the period, what do you set equal to 2 pi? 2x, great. 2x equals 2 pi, and so x will equal pi. So a normal sine function takes 2 pi to go through one cycle. This one takes pi, which means it goes twice as fast as a regular sine function. Okay, and how about the phase shift? Pi over 8, yep, and is it positive or negative? Negative. Okay. They're definitely tricky. How about this guy? So in these things, we're given pictures of sine and cosine functions, and I want you to tell me the picture. Tell me tell me the equation. That thing. Have you got the picture? You need the equation. You're going backwards now. Okay, so the easiest thing to see probably is how long a cycle is, right? So trace that out. Tell me how long is a cycle. What is the period here?
3.
Yep, so the period equals 3. Okay. How is this curve different than other curves you've seen?
Starts to negative.
Yeah, Tani? You don't see how I got 3? So I just chose to start at the y-axis, and I follow the curve until it starts repeating.
Oh, and then, oh, sorry, I didn't see the little 3 on the.
Yeah, there's a little 3 right there. Yep, it's okay. It's not very visible in your notes because they didn't screenshot very well. Yep, there's a little 3 right there. Okay, it does start negative, and that's different, but what I was kind of getting at, I think this thing is shifted down. Does that make sense? So if you thought, if you divided this evenly in half, it has a total height of 6, right? Where would the center be? I think the center's at -2. Do you see that? Because if I put a center at -2, then there's 3 above and 3 below. Does that make sense? So what does the amplitude appear to be in this case? 3. 3. And let's just assume the function hasn't been shifted left or right, but the fact that it would say start on the y-axis means it's what kind of curve, a cosine or a sine?
Cosine.
I think it's a cosine curve. Sine curves start at the origin, so if you had like a shifted sine curve, it would start at this like middle point.
If you shifted it up.
I said you can make it sine if you want to, but it's easier not to, okay? Let's not do the shifted business makes it more tricky. Okay, and would it be a positive cosine or negative cosine curve? It'd be a negative cosine curve because it starts below that middle line as opposed to above it. Okay, so first thing, let's figure out, so we're gonna have negative cosine of, well, -3 cosine, some number with the x. Has our graph been shifted up or down? Let me explain again how I got those things. Let me erase that. Or not, because my iPad's being stupid.
Down 3.
Yep. Okay. Okay, so we know we have a cosine curve. It's been moved down 3, that's why there's a -3. Where does the amplitude go in the equation? In front of the cosine. And because our curve starts below that middle line as opposed to above it, it's going to be a negative. Okay, that's why I got those numbers there. The period affects the number inside the parentheses. So normally we set bx equal to 2 pi, right? And solve for x. Well, now we have the x, we have b times 3 equals 2 pi. We're going to solve for that b. So what would be equal in this case?
3x equals 2 pi.
2 pi over 3. So y is -3 cosine 2 pi over 3x minus 3. That is not the only way to express this picture. You could use a sine curve and do like a left or right shift.
So if we did it from there, then we'd just be shifting or counting from the origin.
Say that again?
So if we did it from sine, then it would be counting from the origin.
If you did it from a sine curve, you probably would, I mean, I didn't even think about how to do it because I thought that it was harder. You could think about that as being your origin and move it left or right. But I don't think that's easier, so I would suggest not going that way. Yeah. Did you have a question?
Sorry, I'm not really seeing how it's down 3, like I don't.
Oh, it's because you have to have a really good picture of what the normal cosine curve looks like. So if on this picture I had just graphed 3 cosine of x, okay, without any of the weirdness, that would have started at 1, 2, 3. And it would have looked like that should be 3 cosine of 2 pi over 3, but
Isn't that just down 2?
Yeah, it should be.
oh, did I mess up? Yep, it is just down 2. You're right. Yep, -2. It should be -2. Yep. Okay, thank you. Of course, if it goes from -3 to -5, duh. Yeah, all right. How about this one? So first of all, where is this thing kind of centered? At 1. Okay, so trace out how long one of the cycles is.
4.
Mm-hmm. So the period is equal to 4. What is the amplitude in this case? 1. Do you think it's a cosine curve or a sine curve? What do you think is easier? Cosine curve. And is it going to be a positive cosine curve or negative cosine curve? Positive. Okay, great. Alrighty. So we're going to have positive 1 cosine of some number with the x. We'll figure that out in a second. How much was this graph shifted? Up 1. Okay. And bx equals 2 pi. So where does that 4 go? And for the x, b times 4 is 2 pi, and so what's your b going to equal? Or pi over 2. So y equals cosine of pi over 2x plus 1.
The transformations are very much the same as the other one, we just need to know what their originals look like.
Yeah, that's the trick. You know what the originals look like, and that's the tricky bit. Yep, exactly. Okay. So one thing that this can apply to is something called simple harmonic motion. So if you have no air resistance and no friction, and you say pull a spring from its resting position, it's going to keep oscillating back and forth forever and ever, and it dampens when you have air, when you account for air resistance and friction. But if you assume none, it does. It just goes forever and ever and ever, and keeps going in this oscillating pattern. So you have a coiled spring, and it's pulled 14 centimeters below its resting position. Wow. I don't know how I did that. Okay, so your spring, here's a picture of its position. So here's time, and here's its position. So they're calling time t, and they're calling the position d. So they say it's pulled 14 centimeters below its resting position. Should that go above or below on the x-axis probably? Below. So it starts off at negative 14. And it says that it completes one cycle in 0.2 seconds. What are they telling you in that? They're telling you the period. So they're saying by time equals 0.2, you're back. So in the middle is 0.1, and it goes up to positive 14, and then back down to negative 14. And this pattern is just going to keep continuing over and over. By 0.4, it's gone through one more cycle. By 0.6, another cycle, etc. So what I want you to do is make an equation out of this. And it's not very hard. It's actually a lot easier than the ones we just did. So is it a sine or a cosine curve? It's a cosine curve. Is it positive or negative? Negative. What is the amplitude? And we know the period is equal to 0.2, right? Because they told us that's what it was. So it takes 0.2 seconds to go through one cycle, right? Okay. So you have negative 14 cosine of some number times x. So bx equals 2 pi. What do you plug into that? Where does it go? In for the x. So b times... It might be easier to plug in 1/5. Yeah. Why is that easier, guys?
Because fractions.
because fractions are fun. No, because you can multiply by 5 and get rid of the 1/5, right? It's a little bit easier to multiply by 5 than to divide by 0.2, isn't it? Yep, so b is equal to what?
10 pi.
10 pi. So the equation is negative 14 cosine of 10 pi x. And one thing that I'm not sure if Alex is picky about, my guess is that it is you do have to use the letters that they gave you as variables. So what did they use instead of x? T. And what did they use instead of y? D. So I personally find it easiest to use x's and y's in the beginning and then change them to whatever variables are asked of me in the end. Does that make sense?
How much has a fill in the blank thing where it already says this variable equals and then you fill in the answer?
That's nice.
Makes things easier.
Yay. Mm-hmm.
Wouldn't it just be easier to write the equation as shifted point 1?
Say that again.
Couldn't we have, like, instead of writing like a negative cosine, couldn't we have just written like, it was more like a positive cosine just shifted to the right?
Oh, yeah, you could have written it as a positive cosine shifted to the right. I don't think that's easier, but I mean, you could have. So what was the equation you would get?
Oh, I didn't write it down, I just thought it would be easier, because I don't like negatives.
You don't like negatives. Yeah, The thing is, if you can come, on top, right on the spot, I'm sure that I could make up a function that would do that, but I don't think it's easier. Because even though this thing was,
When you just had to write like 10 pi.
yeah, so I think,
minus 0.1.
so if you said 14, it'd be cosine of, I think, 10 pi times t minus, well, it moved.
0.1.
Yeah, I think that will do it. So I think that's also right. I mean, Alex should be smart enough to tell you that you're correct when your answer is equivalent. There's lots of ways to write this correctly. I personally find it easier not to mess with shifting left or right. If you dislike the fact that you have a negative sign, you can try it another way and see if it tells you the correct thing, because this probably is the same equation. So, yeah. I don't think I don't know if it's easier or not.
Maybe 0.05, not 0.1.
No, so she's thinking, it depends. So notice how Natalie used a cosine curve.
Yeah.
So in that case, she's thinking,
Oh, yeah,
if
yeah,
you were
yeah.
thinking about using a sine curve, the shift would have been 0.5.
Yeah.
Yeah,
I see.
or 0.05. Yeah, exactly. Weirdness. Okay. I meant to look up how to do part A and then I forgot. So we're gonna skip part A and come back to it. I'm embarrassed, but I can't think this morning because I took NyQuil last night.
It's just period inverse. It's instead of 2 pi over b, it's b over 2 pi.
Okay, so you have a person sitting on this Ferris wheel, and the Ferris wheel goes up and down, and you go around, and your position above the ground is going to go up, down, this oscillating thing, right? So this equation tells you where the person is, their height. So find the period of this function h. So how would you find that? So what's the part that's going to affect the period in this thing? 1.6. You'll say take 1.6 t and you're going to set it equal to, we're skipping part A for now.
Oh,
Okay.
that's what I missed.
We're going to come back to it, we're going to come back to it tomorrow. So 1.6 t equals what? 2 pi. And so you take t will equal 2 pi divided by 1.6. And could you guys that have calculators just do 2 divided by 1.6? Like, ignore the pi. I think it's 1.25, but I want to be 100% certain. Or you can tell me if you agree with my analysis. I said it was 20 pi over 16. You see how I got that? By multiplying both top and bottom by 10. And how does 20 over 16 reduce? 5 over 4 pi. Do you agree with that? So 5 over 4 is 1.25, right? Okay. So the period of h is 5 over 4 pi minutes. Okay. So then I want you to find the maximum and minimum height above the ground in meters. This is actually totally possible. So think about what that sine picture is going to look like. So it's a negative sine picture, right? So how is it going to start? What's it going to do first? It's going to go up or down first? Oh. Since it's negative, it's going to go down first. So its period is 5 pi quarters. What's half of 5 pi quarters? 5 pi eighths, great. And what's half of 5 pi eighths? 5 pi sixteenths. So, and that makes this into 5 pi over 8 plus 5 pi sixteenths, which is 15 pi over 16. And this sine picture is going to initially go down to negative 19.5. It's going to go up to 0, then it's going to go up to 19.5, and then it's going to go down.
Why is it 15 pi over 16?
Because this point right here is 5 pi eighths. Does that part make sense? Does it make sense why this point right here is 5 pi over 16? So the distance from this point, 5 pi sixteenths to 5 pi eighths is 5 pi sixteenths. The next one, see how that's the same distance
yeah.
away? And so then when you add these, you get a common denominator. 5 pi eighths is, multiplying that by 2 over 2, it's 10 pi sixteenths over 5 pi sixteenths. Yeah.
So do 5
So-
over
I
16.
don't know, I'm confused because it says the height above the ground, so that means that they're underground. doesn't it?
There's something I haven't accounted for yet.
Oh, yeah, you guys.
What haven't I accounted for yet?
23.
The 23, that's a great question, but I haven't accounted for 23.4 yet, have I? So this is gonna get all shifted by 23.4, but the thing is, you don't actually need that. Does that make sense? So where is, at which value of t is the lowest point? So this is the value of t that gives you the lowest, right? Which value gives you the highest? This one, right? So the lowest is gonna be when at t equals 5 pi over 16. Where's the highest gonna be? 15 pi over 16.
The question didn't ask for that though, did it?
No, it's just
It asks for the heights, but you're gonna need that to find the heights.
Why can't you just do 23.4 plus or minus 19.5?
yeah.
That's how Alex explains it.
It looks a lot easier too. Because you just shifted it all over.
Oh, of course you could do it that way. Yeah. I was overthinking it. Okay, I'm an idiot. I should just go back to bed. All right, yeah, duh. It's a curve shifted up 23.4, and it does this kind of thing, right? Yes, duh. This distance is negative 19.5, that distance is positive 19.5. Right, so what is the highest point? To be 23.4 plus 19.5. I'm not even gonna try to add that right now.
22.9.
Thank you. And then the lowest would be,
That is 42.
oh man, we're just dying today. 42.9. And the lowest point would be
32.4 minus.
23.4.
Yeah.
It's okay, I have the state minus How much?
3.
There we go. My way would have worked too, it's just it was a lot more work. Yeah, never mind. Sorry. Oh my God. Okay, let's move on to other stuff. Less applied. Haven't shifted tangents yet, have we?
No.
No, okay. So what did tangents picture look like in general? Where did it look? Yeah, it looked like a sort of cubic-ish curve, does that make sense? And it had this repeated pattern. Where were its asymptotes? Pi over 2. So you can think tangent is sine x over cosine x, right? And cosine is 0 at pi halves, 3 pi halves, right? 4 pi halves. So on this picture, I am just going to call this, there's pi halves. Here's negative pi halves. There's 3 pi halves, negative 3 pi halves. And we discussed that tangent does this sort of like SE-shaped thing. What is this 4 going to do to that tangent picture? So if I was graphing 4 tan x, what's one other number that plugs into tangent well? Can you plug 0 into tangent? When you plug 0 into tangent, you get out 0. What about pi quarters? Why is pi quarters nice in tangent? Because it equals 1. Sine and cosine are equal, right? So if you have 4 tangent of pi quarters, what's that going to equal? It'll be 4. It'll be 4 times 1. So it'll be really steep. Call that 2, call that 4, it's way up there. Call that negative 4, it's way down there. So there's, roughly speaking, what one of the periods of that tangent function looks like. It'd be really, really steep. Okay. What is the minus pi 6 going to do to it?
Over 1/6.
Shift it left or right?
Right.
Shift it right pi 6. So the way that we found those was by subdividing the intervals that were pi halves into thirds. So 1/3, 2/3, 1/3, 2/3, 2/3, 1/3, 2/3. So move everything over pi 6, which is how many tick marks are the little subdivisions that I made?
1.
Just one of them, yep. So there's your new asymptote, new center, new asymptote. New center, new asymptote. There you go. What is the period for a regular tangent function? Like what is the length of that pattern? It's kind of hard to see now, but pi. Does this function have an amplitude?
Yes. 4.
No, it doesn't, really. It doesn't have an amplitude because the sine and cosine have an amplitude because they have a highest and lowest point, right? Does this tangent function have a highest, lowest point?
Oh, no.
Does that make sense? So no, there's no amplitude. The 4 does stretch the graph out, but it's not an amplitude. But do you get the basic idea that those shifts that we had from before also apply to this kind of stuff? Okay. All right. So how about this next one? How about tangent of x and tangent of 2x? when we did sine of 2x, what happened to the period? Does it get shorter or does it get longer?
Longer.
Pretty shorter.
Yeah, when we graphed y equal sine x versus y equals sine of 2x, this one oscillated more quickly. Does that make sense? So for sines and cosines, we took 2x and set it equal to 2 pi, right? For tangent, you're going to set this 2x equal to pi instead, because that pi is sort of like the base length
It's the base period.
of tangents, period. Yep. So what is the period of tangent 2x going to be? Pi over 2. Which actually means that, okay, so if this is regular tangent, and we'll call this pi halves, and we'll call this one negative pi halves. As long as you label them, you can call them whatever you want. That has a normal length of pi. Where is this tangent of 2x going to be? Where are its asymptotes going to be? You got to take this thing and chuck it in half, right? So they're going to be at pi over 4. And negative pi over 4. I know, it's nuts. What I'll probably ask you to do, if I ask this in a test or a quiz, just ask you to graph 2 cycles. So on the right side, where is the next asymptote going to be? Oh, I don't think so. So I think this has a width of,
Oh, so there'd be 3 pi quarters.
I think it'd be at 3 pi quarters. Do you guys agree with that? Because it wouldn't be here, it's going to be 0 there, right? But it's this one that's the next asymptote. And that's pi quarters plus pi halves is 3 pi quarters. It'll look roughly like that. You take pi quarters and you add pi over 2, or the length of a period, to get the next one. Yeah.
So I always thought of it as like whatever number is being multiplied by x, that's how many periods would fit in the original.
That's also a way to think about it. Yep.
Okay.
Mm-hmm. I think that's true for this one as well.
Well, I don't think so because it technically doesn't fit in the original though.
It does though. So it's just that it's shifted over. So the original is from negative pi halves to pi halves, right? But it is just the case that if you took this, you shifted it back, they would fit inside of it, but it doesn't mean that, I think what doesn't work for you is they don't actually land inside of that. Does that make sense? But that does tell you that, yes, in the length of time it took tangent to go through one cycle, there'll be 2 of them in that same length, but the thing is that they'd be broken. Yep, that's a great way to think about it though. Okay. So mostly of it, you understand that tangents period is different than sines and cosines. Does that make sense? So if you want to find the period of tangent, or actually cotangent, we didn't do a cotangent one, but cotangent had asymptotes at all of the pi's and looked like this, right? Its length of a cycle is also pi. So when you're trying to find the period of tangent or cotangent, what do you solve? You solve bx equals pi instead. So find the period for these functions. What would you be solving for A? Mm-hmm. And so x would equal pi quarters, right? And if you were to actually graph that tangent, your first asymptote would be at pi eighths, and the other one's at minus pi eighths. It's pi quarters on both sides. How about this one? What do you solve? say pi over 2x equals 2 pi. So multiply the 2 over and you have pi x equals 2 pi. And so x will equal 2. So if you were to graph that tangent, where is the asymptote on the right of the x-axis? At what number? It's a total width of 2 and it spans both sides. So it's 1 on this side, -1 on this side. Going back to A, that picture would look kind of like this, right? What is the negative going to do to the picture in B? It flips it, so it usually goes up initially. Now it's going to go down like this. And cotangent's pretty similar. So set 3x equal to pi. And so you get x equals pi thirds, yep. Okay. So the only ones we haven't done yet are what? Secant and cosecant. We're going to do 2 of those. And I know how Alex explained this, because I did actually look it up. They explained this as the first thing that you should do is you should graph the, what they call the guide function, I think. So when we first graphed secant, we started by graphing cosine, right? And then use that cosine graph to graph the secant graph. We're going to do this pretty similar, just we're not going to graph plain cosine. We're going to graph 2 cosine of x over 2. Does that make sense? Okay. So what is the period for this? You set x over 2 equal to 2 pi. The period is 4 pi. So if this is 2 pi, will my function have completed an entire oscillation by then?
From where?
It will if you go from 0. Sorry, I should specified. From 0 it will not, right? But from -2 pi it will, right? Okay. Where does the cosine function start if it's 2 cosine? 2, so let's call this 2. We're going to start there. And then when is my function going to cross the x-axis? At pi, yep. And by 2 pi, it's going to be at -2. And does the same thing on the other side. Crosses at -pi. By -2 pi, it's down at -2. So that is actually one cycle of this cosine picture. To get the whole thing, you'd have to go to 4 pi. Where's your secant thing going to have asymptotes? At pi, and -pi. And if I had drawn this a little bit bigger, like say I had gone to, that was 3 pi, I'd have an asymptote there as well, right? And also at -3 pi. And then what does your secant function look like in between those asymptotes? Like parabola-ish? Yep, exactly. So it's parabola-ish, parabola-ish, parabola-ish. Question, is the period for the secant curve the same as the period for the cosine curve? Now think for a second about that. So a period means you have to have gone through one entire cycle, meaning all the sort of like unique values of x and y, or how wide is the picture that you need to get the whole picture? Is it 2 pi wide or is it 4 pi wide?
4 pi.
The whole picture is 4 pi, right? both the up part and the down part. Does that make sense? So this has the same period as this cosine picture. Because you have to, both the upper part and the lower part count as part of the period, even though they are related to each other. So both pieces can constitute one cycle. Okay, and one more weird one, and we'll be almost done. So 3/2 cosecant of 3x. Oh gosh. Okay, what's this related to? 3/2 sine of 3x. Okay, so we're gonna let 3x equal 2 pi. So what's x gonna equal? 2 pi over 3. So I'm just gonna choose to label these axes by pi thirds. That's gonna be 2 pi thirds. Say so. What's halfway to 2 pi thirds? 2 pi 6, which is pi thirds. What's halfway to pi thirds? Pi 6. And this one here will be pi thirds plus pi 6. I think that's going to be pi over 2. Okay. Okay, so where is this sine curve going to start? At the origin, yep. And if we call this 1, 3/2 is 1.5, right? When does it go up to 1.5? Pi over 6, yep. By pi thirds, it's back at 0. By pi halves, it's at negative 1.5, and 2 pi thirds, you're back at 0. Okay, so there's your sine picture. Stick in your asymptotes. Where are your asymptotes? So 2 pi thirds. Pi thirds also 0, yep. Pi thirds, 2 pi thirds. And then there is your cosecant function. How long, what is the period of this cosecant function that you drew? 2 pi over 3, right? So I will do example 11, even though we're going to go like a minute over because it's not going to take that long. So how do you find the period of secant and cosecant? What do you set the bx equal to in this case? 2 pi. So the only times you set that equal to pi is when you're looking at tangent or cotangent. So for A, you'll set pi x equal to 2 pi. So x would equal 2, I think just 2, right? Because if you divide by pi, the pi's cancel, right? In B, you'd set 2 pi x equal to 2 pi. Then what would you get? Just 1. Yep. And this one, part C, is a bit tricky, but not really. Does this plus pi affect the length of the period? What does that do to the picture? It shifts it left or right, correct? So what affects the period is the fact that this is just x, right? So if you set x equal to 2 pi, your period is just 2 pi. So thanks for being patient with brain dead me.